Hello, my name is Ramin Hujati, and today I'll be giving an introduction to Averant Solidify Toolset. The main tools in Solidify are automatic checks. These are like lint checks except that they use a formal verification engine, property verification, coverage analyzer, sequential equivalency checking, branch and target reachability analyzer, timing constraints verifier, these are false paths and multi-cycle paths, and finally protocol checker, and this thing's protocols like ARM AMBA. The automatic checks are grouped into a set of checks. For example, the dead code check contains a set of checks, and so does deadlock and live lock. Here is an example of a deadlock, and in this design you fall into this state and you never come out of it, and Solidify's auto check can catch problems like that. They also can catch flip-flops that don't get reset even in the presence of complex reset circuitry. They can catch bus contention when two agents or multiple agents try to write a bus. They can catch clock domain crossing issues, and these involve both structural as well as functional problems such as gray value violations. In property verification, which is the heart of Solidify, it supports all major assertion languages: SVA, system verilog assertions, PSL, OVL, and HPL, which is a language that was designed in-house. It has an easy-to-use GUI. It has intuitive debugging with waveform displays, and it produces test benches and vectors for simulation, and it integrates with simulators and debug tools such as Verdi. It also includes a coverage technology to ensure completeness of properties, and it has tickle scripts that allow for customizing flows. Here's the Solidify GUI, a snapshot of it. Here's the module browser. Here are where the properties go, and these buttons allow us to add properties. Here are where the messages go. Here's the code, properties, and then a property browser, which includes both properties and assumptions. You could also interact with Solidify from the command line interface down here. In verification, there are multiple ways to do this. There's one button called Auto Verify, and it allows for automatic verification. There's also manual verification, which allows the user to have fine control over the settings. And finally, there's bug hunting for deep counterexamples. When a property fails, a debug trace is displayed, and that debug trace contains only the signals and their applicable values. You could see in here, this is a Solidify generated signal, and it tells us where the property fails. Then there's clock, and then there is the rest of the signals needed to debug the property. Solidify includes code coverage, and code coverage takes a set of properties, and then it tells the designer what areas of the design are still uncovered. For example, in this up-down counter, we're saying that the UD0 is not covered and it needs additional properties. There's a branch and custom target analysis tool. When you run it, you get a report such as this, and the branches are automatically generated by Solidify, and you could see some branches were quick to reach, like 2 or 3 cycles from reset, and some of them took 129, 130 cycles to reach from reset. There is a sequential equivalency checking tool in Solidify, and as we know, power optimizations are now an important part of IC design flows, and whether they're done manually or automatically, they need to be verified. And in SEC, you take the original RTL, you take the modified RTL, and you use equivalency checking to show that for all input sequences, the output sequences are also the same. Solidify also contains timing verification tools, and here we're showing a false path, which are paths which cannot be responsible for delay but are critical. You use a language such as SDC to specify such paths, and Solidify can take SDC constraints and tell you whether they hold up the design or not. Finally, protocol checking is an easy-to-use interface to using property verifications. There's no properties to write. The user basically selects a set of protocol rules and push a button, and it shows what properties are failing. Here's the red for failing, and what properties have passed and what properties the tool is still working on. This concludes my talk. Thank you very much for watching.